Welcome everyone. In this video we will be learning about the serial communication with respect to PIC16F microcontroller. So before we actually get into the programming part, so we must know about some of the basic terms that are frequently used while programming the serial communication with respect to the PIC16F microcontroller. So in the previous classes, you might be knowing that PIC16F microcontroller has 5 input-output ports where we can send multiple bit of data over multiple wires at one time. So that what we call it as a parallel communication. On the other hand, serial communication implies sending one bit of data. So for that purpose, a single wire would be sufficient. So serial communication is mostly preferred for a long distance communication because of the cost and some other aspects. So it has its own advantages and disadvantages. So that is not exactly the scope of this particular topic. There are two types of serial communication standards available, that is asynchronous and synchronous. So in this slide, we will be learning about what exactly asynchronous serial communication is. So in this case, the transmitter and receiver are not sharing a common clock. That means they are running at their own speed. They have their own clock. Suppose we want to transmit a 1 byte of data from a transmitter to the receiver through a single cable. So this data has to be packed because of there is a protocol, that is a mutual understanding between the transmitter and receiver. So we are going to add some of the extra bits. So they are the start bit, the stop bit and the parity bits. So the data, 1 byte of data that we are going to transmit is added along with the extra bits. Then it is transmitted over a single cable. So at the receiver part, the receiver first will extract these additional bits which were added by the transmitter using its own clock, and then it will collects the 1 bit of data which is in the serial form and converts back into the parallel form. So the transmitter has to convert first the parallel data into the serial using parallel to serial converter, whereas the receiver, when it collects the bit by bit data, so it has to convert the serial bit back into the parallel using serial to parallel converter. So we will see about the terms that we have used in the previous slide. So first one is the start bit. The start bit, as the name indicates, that this bit will give the information like after the start bit we are going to have the actual data bits. Then stop bit will indicate the end of the multiple data bits which were transmitted. Then there is a parity bit. This bit is mainly used for error detection and it is optional. So if in case the data is corrupted while it was transmitted, so there was multiple number of ones and multiple number of zeros, so how exactly or how many number of ones or how many number of zeros are there when it was transmitted, and how many number of ones and how many number of zeros were received. So if it is not matching, means that is the data is corrupted. So for that purpose parity bit is used. And data bits is the actual data that is supposed to be transmitted over a single cable. Again, this data bits depends upon the protocol. It may be a 1 byte of data, that means 8 bits, or it can be more than 8 bit of data. So bitrate is called as number of bits which are transmitted every second. So it is a BPS. So then there is one more unit which is used more commonly in the serial communication, that is a baud rate. So there is a slight difference between the bit rate and the baud rate. So baud rate indicates the number of symbols which are sent every second. So where one particular symbol can represent more than one bit of data. For example, if we are sending multiple ones, for example 3 ones, we are going to transmit from the transmitter to the receiver. So it is a one symbol. That digit 1 is a one symbol, but there are multiple ones. So that is the difference between the bit rate and the baud rate. So in the PIC16F877A, so with every clock tick, one bit is sent, so which represents the one symbol. So in this case, we consider the bit rate and baud rate as a same concept. So next term is a throughput. It is actually how much data is transmitted per second. So we have understood that, for example, to transmit 1 byte of data, we have to add some additional bits which are not the data, which are the overhead. So throughput indicates how much data is exactly transmitted per second, excluding the overheads. So for example, if we have 115200 baud rate, which is nothing but the bits per second, and if we are using the protocol which has one start bit and one stop bit and no parity bits, then the effective throughput for 8 bit of data will be 115200 into 8 divided by 10. That means actually it is a 8 bit of data, but we made as a 10 bit of data and then we transmitted. So that means actual bits per second will be 92160. So in the synchronous serial communication, the transmitter and receiver are running at the same speed, because along with the data, the clock is also sent as a separate signal. So because of this same speed between the transmitter and receiver, here there is no additional bits are needed to be attached along with the data before it was transmitted. That means the transmitter first converts the parallel data into a serial using its own clock. Then it will provide the clock also a separate signal to the receiver. So because of this, there is no start, stop or parity bits are required. So in the receiver side, it will extract the data using the clock which was provided by the transmitter. Then it will convert the serial data back into the parallel form. So there are different serial communication standards are available. So some of them are RS-232, Serial Peripheral Interface, System Management Bus, Serial ATA, I2C, CAN bus, and the LIN. So in the PIC16F microcontroller, which has a UART, that means Universal Synchronous Asynchronous Receiver Transmitter, that means it has both asynchronous and synchronous features. So but we are limiting our study only to the asynchronous feature. So in this slide we will learn about the terms like simplex, half duplex and the full duplex. So simplex, where the data can go only in one direction at one time. That means the data is transmitted from the transmitter to the receiver. Half duplex, the data can go in both the direction using a single cable, but not at the same time. For example, at the side A, transmitter is sending the data to the side B receiver. So we can achieve the data transfer from the side B transmitter to the side A receiver, but not at the same time. The full duplex, where the data can go from side A to the side B at the same time without the need of depending on a single cable. That means there are multiple cables are there between the multiple transmitters and receiver. So in the PIC16F series, there are two pins are dedicated for the serial communication. So that is the transmitter and the receiver. These pins are part of the port C pins. So port C pin number 6, which will also act like a transmitter line, and port C pin number 7, that is RC7, which will also act like a receiver pin. So the 6 registers which have to be used while programming the serial port are the SPBRG, TXREG, RCREG, TXSTA, RCSTA, and PIR1. So the structure of these registers and the usage of these registers in the programming part we will be learning in the next slides. Thank you very much.